Hi guys, so in this video we're doing question 4, of which this is a momentum type question, of which this is a different one, unlike the usual ones that we used to, whereby we asked about the linear conservation of momentum. But this one particularly, it's the impulse, right? Good. So let's begin. Alright, question 4.1. Alright, so the question statement reads: the bounce of a cricket ball is tested before it is used. Now, the standard test is to drop a ball from a certain height onto a hard surface and then measure how high it bounces. Right? So, during such a test, a cricket ball of mass 0.15 is dropped from rest from a certain height, and it strikes the floor at a speed of 6.2 meters per second. The ball bounces straight up at a velocity of 0.62 meters per second to a height of 0.65 meters, as shown in the diagram below. Now, the effects of air friction may be ignored as always, right? Good. Now, 4.1, define the term impulse in words. So, impulse is defined as what? Is defined as the product of the force and time during which the force acts, right? As I always say, I do not write definitions, I only state them. I repeat, impulse is the product of the force and the time during which, of the force and the time during which the force acts, right? Right. Right. Now, 4.2, calculate the magnitude of the impulse of the net force applied to the ball during its collision with the floor. So they want us to find what the magnitude of the impulse of the net force applied to the ball during its collision with the floor. Okay. Now, in order to find that, we know that impulse is defined as the F net. Change in time is equals to what? Change in P. So we need the momentum, right? So we know that change in momentum basically is M multiplied by VF minus V initial, and the mass of this ball is what? It's 0.15. The V final, it is 0.62. Here it is, read up, minus the V initial, which is 6.2. Negative 6.2, by the way. Why? Because this is the velocity at which it went down with, and the what is this? The 3.62 is the velocity at which it went up. Right? Yeah. So in this case, I took downwards as negative, right? I took downwards as negative and up as positive because this is the velocity of which it went up with, right? You're more than welcome to change it up, but then our answers will be the same in the end. So our answer is then 1.473 newtons per second up, right? Because it's going to be positive. Now, even if you said downwards it's positive and up it's negative, it was just going to be up, right? Now let's move to 4.3, which is the last question. 4.3, to meet the requirements, a cricket ball must bounce to 1/3. This is important. 1/3 of the height that is initially dropped from. Now use energy principles to determine whether this ball meets the minimum requirements. Now this is a tricky question, but it won't be hard for us because they already gave us a hint to use the energy principles. Now we're going to use mechanical energy before is equals to the mechanical energy after, right? So mgh plus 1 over 2. I think you don't need to write, okay, but it's fine. 1 over 2 mv squared, it's equals to mgh plus 1 over 2 mv squared, right? Before and after. So they want the height, right? Since they want the height, this is the initial, this is the final. They want the height, which is this part here. Let me use the blue marker. This is this part. They want the height of which the ball must reach, right? So initially we know that the mechanical energy is zero. Why? Because it starts at the bottom, right? The only thing that it has is the kinetic energy, which is 0.15 multiplied by the V. Now the V, we're going to use what? 6.25, okay, squared, of which the mgh, we then gonna say mgh for the final one, we don't know the height. Right. And the kinetic energy is what on this side? The kinetic energy is zero. Let me remove this. Is zero, right? Okay. Then our height is going to be 1.96 meters. Now, before I finish this question, we still left it some part. Let me explain what I did right here. Right. So let's read the question. They said a cricket ball must bounce 1/3 of the height that it is initially dropped from. Initially dropped from, right? From the top. Top, just say top, bottom. Right? Now, from the top, I know I don't know the height basically. I don't know this height that the ball was originally dropped from, right? But I do have the height of, what is this? The height, which is 0.65, but it's not the original height that the ball fell from, right? It was dropped from. So at the top, I do know that I do not have the mechanical energy, which is this side. I do not have the mechanical energy at the top, but at the bottom, which is the fire, which is the initial, basically, I did it vice versa, which is the initial. I do have what? I do have the kinetic energy, which is the energy used to reach the bottom. So in simple cases, the way that I did it, I started with the bottom, since I know this ball will come down and will not have a will not have a potential energy, but will have a what? Will have a kinetic energy. So yeah. So after you found the height, since you know that it has to be 1/3, you just have to say 1.96 divided by 3, which is 0.65, right? And yes, it does meet the minimum requirements. Why? Because it reached this height here, 0.65. I didn't want to say in the beginning while we're doing this question, right? So yeah, but then to just simplify it for you, we can begin it like EM final is equals to EM initial, because in this way I think majority of the students will understand. If I say it like this, you start at the top and then you go to the bottom, yeah, and then you just swap everything, take this to the other side, this to this side, and then yeah, you should be able to get the same answer as me. And when they said you should prove using mechanical energy, you do know that it can reach a certain height, but then you have to prove it, that with this ball can it reach it, right? So basically this is the minimum height that each and every cricket ball has to reach. Well, I hope that y'all enjoyed this video as much as I did making this video, and I will see you guys in the next one.